Okay, so in this video we're going to start talking about circuit diagrams. And so we've been talking about components of a circuit for the last couple of videos, but in this video we're going to start looking more about how you actually draw circuit diagrams and how you interpret circuit diagrams, and then we'll also talk about different types of circuits like series and parallel circuits later on. Okay, and so as you can see on the slide, scientists usually draw electric circuits using symbols. And so, for example, um, if you had a circuit that might look like this in real life, okay, so for example, we have like a battery and we have like a light switch connected to it with wires, and then we have a light bulb connected to it. Rather than draw this complicated picture, we use specific symbols in physics to draw circuits. Okay, and so what you see over here on the right is basically this circuit drawn using certain types of symbols. And so we're going to talk about the different symbols, but here you can see this is like a battery, just like a D cell battery that you might buy at the store. And the symbol for a battery, or what we call a cell, as you can see in the diagram, is you have a long line and you have a short line, and I'll talk more about that in a minute. Rather than having like a light switch like you might find on your walls, the physics symbol for a switch, what's called a switch, is this symbol right here. Okay, you see the two dots, and then the white part is the switch, and when the switch is open, there's not any current flowing, right? Because we talked about how you have to have a closed conducting path to have a circuit. And so when the switch is open, there's no current, and then when you close the switch, there is current, and the current's going to flow around the circuit. And then rather than have a lamp, we draw a circle with an X through it, and that is the symbol for a lamp or a light bulb. Okay, and so knowing the symbols for different components allows you to draw and interpret basic circuits. Okay, and so that's the first thing we're going to talk about in this video. Now, as you can see here in the notes, when we talk about a cell, that is your voltage source. Okay, so that is like your battery. This is the place where the voltage and the current are coming from. Okay, now when you draw a cell, and we saw a picture of a cell before, that's where you have like one long line and one short line. Okay, the longer side is always the positive side of the cell, the positive side of the battery. Okay, anytime you look at a battery, you see like one side says positive and one side says negative. So using circuit diagram symbols, the longer side is always the positive side. And by convention, the current is always going to come out of the positive side of the cell. So for example, when I'm looking at the circuit diagram and I see the way it's drawn, I know immediately that the current is going to come out this way, and it's going to flow around the circuit, and it's going to go counterclockwise as long as the switch is closed. It's going to go this way, and I know which way it's going to come because, again, current always comes out of the positive side of the cell and then goes back into the negative side of the cell. Okay, that's just the convention that we use in physics. Okay, so first of all, make sure you understand that about cells. Okay, long end is positive, short end is negative. Second of all, when we talk about a lamp, we're talking basically about like a light bulb. Okay, now something that you should know about light bulbs is that the brightness depends on the power dissipated through the light bulb. So in the last video, we talked about the three power equations, like we had, PIV, we have P equals I squared times R, and then I think P equals V squared over R. We talked about the three power equations. Okay, so something you need to know about light bulbs is that the brightness of a light bulb or the brightness of a lamp depends only on the power dissipated across that light bulb. Okay, so if you had two light bulbs, whichever one has a higher power is going to be brighter, all other things being equal, of course. Okay, a resistor was not on the last circuit diagram that we saw, but basically a resistor is a small device that is used to add resistance to a circuit, and I'll show you what that symbol looks like here in just a minute. We did see a switch, which is like exactly the kind of switch that you're familiar with, like when you turn off the lights, you flip a switch. Okay, basically when you flip it one way, it like opens up a little gap so that current can't flow, and when you close the switch, then you have a complete closed conducting path, and the current can flow. Okay, so we saw a switch, and then obviously wires. Wires are drawn as lines on a circuit diagram, and so anything that's just like a straight line, that's just like a wire. Okay, usually made of copper, but can be made of other conducting materials like other metals, and that's what easily allows electrons to flow through the circuit. Okay, and so most of those different components, we saw what the symbols look like on the last slide. So let me go back so you can see this. Okay, but we saw, for example, the cell. Okay, so this is a cell right here. We saw the lamp, that's the circle with the X. This squiggly line right here, okay, that is the symbol for a resistor. Okay, so this is a resistor. A resistor, again, is just like, it's a little tiny circuit component. You can buy them like on Amazon for really cheap. But basically, it's just this little thing that you put in your circuit to add resistance for different reasons, in case you want something in your circuit that had resistance. The switch we talked about, and then, you know, the red line here is just like wire. Okay, so those are the different components of a circuit diagram. So pause it there if you need to add any of that to your notes. Okay, so moving on. You're obviously not going to be drawing circuit diagrams, but you do need to be able to interpret them, and so make sure that you have all of this information down in your notes. Okay, the longer end of the cell is the positive side, current always comes out of that side, etc. Okay, so just to show you an example of a circuit diagram, here it says in the space below, draw the circuit diagram for the picture shown to the right. And so obviously you can't do that through the computer, and so I'm going to draw this for you. So if you look at the picture over here, we can tell this is a battery. Okay, and let's see, we can tell that this is a light bulb. Obviously it looks like a light bulb. And we can tell this is like a light switch. Okay, so the way I would draw this is, first of all, I would do the cell. So one long end, one short end. Okay, and a cell is always going to have a certain amount of voltage. Like if you go to the store and you buy like a AA battery, if you look on the AA battery, it actually says like 1.5 volts on the side, like in tiny letters on the cell. Okay, and so there's always going to be like a voltage of any given cell. Okay, so I draw the cell, and then I draw the wire, and then for the light bulb, remember that's just like a circle with an X, and then the switch, I draw two lines like this, and you always draw the switch open so that you can tell that it's a switch. Okay, and then this goes back into the negative side of the cell. The current is going to flow out of the top because that's the positive side, and it's going to go clockwise around and back into the negative side. Okay, so that's how you would draw a circuit diagram for this basic circuit right here. Okay, so pause it there if you need to look at that some more. Okay, so moving on. Let's see. Example 2, I will go ahead and do this one for you because, again, you can't really draw this through the computer. But example 2 says, draw a simple circuit diagram containing a cell, a lamp, a switch, another lamp, and a resistor in that order. Alright, so we have the cell, and we want a lamp. Okay, so I'm going to do a circle with an X. A switch. Again, you always want to draw the switch open so you can see it. Another lamp. And a resistor, which is that squiggly line. Okay, and that's all I'm asked to draw. And that completes my circuit. Okay, so pause it there if you need to look at that some more. Okay, so now that you've seen basic circuit diagrams, let's take a look at different types of circuits. Okay, now there's two primary types of circuits that you need to be aware of. Okay, and the two basic types of circuits are called series circuits and parallel circuits. Okay, in this picture right here, you can see the difference between a series circuit and a parallel circuit. On the left, you can see like the actual picture. On the right, you can basically see the circuit diagram for the same type of thing. Okay, now basically I'm explaining this in simple terms now, and I'll be more specific later. But in a series circuit, there's basically only one pathway for the current to flow. Okay, and so notice in the series circuit, the current is going to come out of the positive side of the battery, or out of the cell, and it's going to go counterclockwise, but it only has one path that it can possibly take. Okay, in a parallel circuit, that's not the case. Okay, so in a parallel circuit, what happens is the current comes out here, and then right here, it gets to what's called a junction, where the current can actually split. So if you imagine, we've talked about, like, wire kind of being like pipes, and the water flowing through the pipes is kind of like electric current. Okay, so if you imagine like a pipe that has water flowing through it, it's possible for the pipe to split and go to two different locations. Okay, the same thing is going to happen here with the current. So the current flowing out of the cell can split right here at this junction, and some of the current can go that way, and some of the current can go that way. Okay, but what's going to happen is the current is going to reach this point over here, and it's going to recombine back into the original current and then keep going. Now, the key characteristic of a parallel circuit is that you have multiple pathways that the current can take. Okay, so there's always going to be a split in the current. If you look at the circuit diagram over here, you can see in the series circuit, the current comes out, but there's only one pathway that current can take. There's no junction. Okay, whereas with the parallel circuit, the current comes out here, and this point in the diagram, the current can split. Some of it can go this way, some of it can go this way. Okay, and then it can come back together right here and then go back into the negative side of the cell. Okay, so that's basically the difference between a series circuit and a parallel circuit. In a series circuit, there's only one path that the current can take. In a parallel circuit, there's multiple paths. Okay, now I can get a little bit more detailed in a few minutes, but that's basically the difference. Okay, so pause there if you need to add that to your notes. Okay, so on this slide, you can basically just see like the difference between a series circuit and a parallel circuit. Notice that in a series circuit, everything is in a row because there's only one path for the current can take. And so if you imagine 3 light bulbs all connected in series, if one of those light bulbs goes out, because there's only one pathway for the current to take, if one of those light bulbs goes out, the current is going to stop completely. Okay, that means all of the light bulbs are going to go out. If one goes out, they all go out because there's only one pathway. Whereas in parallel, you have many paths for the current to take, and if one of the lights goes out, the others are going to stay on because the current can just bypass the broken part of the circuit because there's multiple pathways in a parallel circuit. Okay, so just to get more specific about the difference between a series and parallel circuits, here's some important details that you need to know about the difference between series and parallel. In a series circuit, the current through every component is the same. In a series circuit, the current through every component is the same. The voltage is usually not the same, but the current has to be the same in series. The reason is in a series circuit, because there's no other pathways, there's only one path that the current can travel through. That means it has to be the same throughout. Okay, in a parallel circuit, the currents are not going to be the same because the current can split because there's different pathways. However, in parallel, the voltage across each component is the same. Okay, so in series, the current through each component is the same. In parallel, the voltage across each component is the same. Okay, so that's just a detail that you need to know about the difference between series and parallel. Make sure you add that to your notes. Okay, so I'll give you a second to do that. Okay, so series circuit, the current is the same, voltage is different. In parallel circuit, the voltage is the same, but the current is different because the current can split. Okay, now in real life, we actually have combination circuits all around us, combinations of series and parallel. Just to give you some examples, parallel circuits, you usually see most circuits like in your house are wired in parallel. Okay, so for example, if your light bulb goes out, your refrigerator doesn't stop working, right? Everyone knows that. Like if you flip a switch to turn out the light, it's not like everything in the house turns off. That doesn't make any sense. So usually house wiring is done in parallel so that each plug or each outlet is on its own separate circuit. So if one stops working, everything in the house can still function correctly. Okay, so your house is usually wired in parallel. most Christmas lights are also wired in parallel, because if you, let's say you buy Christmas lights and you have like 1,000 tiny light bulbs, if one of them goes out, you don't want the other like 999 light bulbs to go out, because that would be a waste of money. However, series circuits are cheaper to do because it's number one, it's easier to do the wiring, and then number two, it takes less wiring to do because you don't have to do all the different loops. You can just do like one continuous loop. Okay, and so series circuits are sometimes used to save money, especially when you're buying like Christmas lights. Sometimes what you do when you buy Christmas lights is part of it is in series and part of it is in parallel. So like they might have the lights in strands, and if one of the bulbs in a strand goes out, that strand might go out, but the other strands of lights might work. Okay, and so a lot of the time you have like combinations of series and parallel circuits like combined. Okay, but those are where you would see series and parallel in real life. All right, just to give you a few quick examples of what this might look like in a circuit diagram. Example 3 says, draw a circuit diagram with a 9-volt cell, a switch, and three 3-ohm resistors in series. Okay, let me make this a little bit bigger so you can see this. Okay, so let's say we were asked to draw the circuit, 9-volt cell, a switch, and three 3-ohm resistors in series. Okay, so remember in series, so here's a cell, this is 9 volts. In series means there's only one pathway. Okay, so it doesn't really matter where I draw the resistors as long as there's only one pathway. Oh, I think I forgot the switch. Well, pretend there's a switch in there. I don't want to erase it and do it again. But this is 3 ohms. This is 3 ohms. That's the resistance of each one. And this is 3 ohms. And they're all drawn in series. Okay, and so that's how you might draw that simple circuit diagram in example 3. Pause it there if you need to look at that some more. Okay, and then example 4. Example 4 says, draw a circuit diagram with a 9-volt cell, a switch on the main path, and three 3-ohm resistors in parallel. So basically the same type of deal, except now we want the 3 resistors to be parallel instead of series. Okay, so let me show you what this might look like. Okay, so I'm going to draw my cell. Long end is positive, short end is negative, 9 volts. I'm going to draw my switch this time so I don't forget. Okay, so there's my switch. And then in parallel means that each of these resistors needs to have its own pathway. So let's say I do one like this, and then I do another one like this, and then I do another one like this. Okay. Notice, by the way, that parallel is always more complicated to draw than series. Okay, and so we talked about before, like one of the advantages of like a parallel circuit is if one part stops working, the other parts still function because there's these like alternate pathways the current can take. One of the disadvantages is that parallel circuits are more complicated. Okay, so keep that in mind. Okay, so that is example 4. So now you should be able to recognize like a circuit drawn in series versus a circuit drawn in parallel. So pause there if you need to look at that some more. Okay, I think I'm going to go ahead and stop the video here, and we will continue talking about circuits, series circuits and parallel circuits in the next video. As always, please let me know if you have any questions, and I'll see you guys in the next video.